Hey everyone. Now we're going to get into lines, which is one of the very most important and in some ways easiest things to learn this semester. Easy both because you've maybe seen them before and also because the algebra is pretty easy. So anyway, a line is anything of the form ax plus by is equal to c. Okay, let's just take an example and graph it and see once what we get. So recall the Cartesian plane. If we have 6x plus 3y is equal to 12, and we want to draw a picture of that. Remember what Descartes said about drawing pictures? We want to draw a picture of that. Then we want different values x, y, which make that statement true. So maybe the most important points on a line are the intercepts. It's where it may or may not cross the y-axis and the x-axis. And to find them, let's define the x-axis. Notice that the x-intercept is where the y-coordinate is 0. So if we set y equal to 0, can you do it in your head? If you set y equal to 0 and solve for x, you're going to get 6x is equal to 12, which means that x has to be 2. So there's the point right there, 2, 0. Okay? Similarly, if you want to know where it crosses the y-axis, notice it crosses the y-axis when the x-coordinate is 0. So you make x 0 and you solve it for y, and you see that y's got to be 4. So there's 1, 2, 3, 4 right there. So there's the point 0, 4. So those 2 points are on a line, and it only takes 2 points to determine a line. So, whoops, too early in the morning. Try it again. That's a little better. So there's the line, okay? Looks like that. So the line looks like that. If you want to find other points on this line, then the easiest way to do it is to first solve it for y. Let's do it. Let's first move the 6x over, and we're going to get 3y is equal to negative 6x plus 12. And then we can divide both sides by 3. And you're going to get y is equal to, well, let's see, when you have a plus b divided by c, you have to divide each of those things by c. So you're going to have 6x divided by 3, and the 3 goes into the 6 twice, so you're going to get negative 2x, and then 12 over 3 is 4. So there's the equation of the line in maybe a little more useful form. And then once you have that, you can find lots of values on the line just by choosing whatever x values you want and then finding the corresponding y value. So for example, if x is 0, then y is going to be 4. We already have that one. See that? Let's throw in some other ones. If x is 1, then you're going to get negative 2 plus 4 is 2. If x is 2, we're going to get negative 4 plus 4 is 0. We already have that one. See that? If x is 3, you're going to get negative 6 plus 4 is negative 2. Maybe we should throw in at least one negative one. If you put in x equals negative 1, negative 1 times negative 2 is 2. 2 plus 4 is 6. So we've just effectively found how many points? 1, 2, 3, 4, 5. 1, 2, 3, 4. One more yet. This is 1, 2, 3, 2, 1, 0, negative 1. X is negative 1, x is 0, x is 1, 2, 2 and 3, yeah. Okay, there we got them all. Okay, so they all line up, form a line. Okay, once you have a line like that, you're interested not only in what points the line goes through, but one of the most important things about the line is called the slope. The slope is telling you whether the line, as you go from left to right, whether the slope is going downhill, that's a negative slope, or going uphill, that's a positive slope. Okay? And if it's positive, it can be a big positive number, which means it's very steep, or it can be a very small positive number. Similarly, for negative, it can be a small negative number or a big negative number, very steep. Okay? So all those things correspond to the slope. The way you get the slope is you just take any 2 points on the line. If you have the point x1, y1, which is a point on the line, and another point x2, y2, which is a point on the line, all you do is, either one, it doesn't matter, as long as you're consistent, you take the difference in the y values divided by the difference in the x values. And so if you're going to start with this one, if you go y2 minus y1, then you have to divide it by x2 minus x1. Okay? If you subtract this one from this one, then you also have to subtract this one from this one. So let's go ahead and do it for this particular line. What are a couple points to take? Let's take the point, let's take 1, 2. Here's the point 1, 2. And let's take the point 3, negative 2. Okay, here's the point 3, negative 2 right there. Okay, I could choose any points I wanted, but let's just take those. So what should we do? Let's let this be our point 1 and this be our point 2. So I'm going to go negative. So here's the slope. By the way, for some reason we generally use the letter m to stand for the slope. So it's going to be negative 2 minus 2 on top. And on the bottom, you're going to get 3 minus 1 on the bottom. See that? So negative 2 minus 2 is negative 4. 3 minus 1 is 2. And so that gives us a slope of negative 2. Okay, if I had done it the other way around and subtracted this one from this one, I would have gotten 2 minus a negative 2 on top, and then I would have had a 1 minus 3 on the bottom. 2 minus a negative 2, those two cancel, so I get 4 on the top. 1 minus 3 is a negative 2 on the bottom, so notice I get the same slope as before, negative 2. So negative 2 tells me that it's going downhill. It also tells me it's fairly steep. And more specifically, it tells me that for every step I take in the x direction, let's do it like this. If I start right here, if I take 1 step in the x direction, I'm going to go 2 steps in the y direction. The slope is sometimes written as the change in y. The little triangle there is a mathematical symbol for change. Delta is another word we say. Delta y over delta x. The change in y over the change in x. Sometimes you may have heard it this way. It's called the rise over the run. Okay, it's how much it changes in altitude divided by how much it changes horizontally. So in other words, this particular line, for every step I take in the x direction, I'm going to be going down 2 steps. If I move 1 step to the right, I'm going to be moving down twice. So that's the slope. Okay, that's the idea. Let's see what else we want to do here. Let's look at some special cases of this equation for lines. If a happens to be 0, then we just get by is equal to c. So for example, if I had 0x plus 2y is equal to whatever, 7, then I can disregard it, and I can solve it for y. Y is equal to 7/2. So what does that line look like? That line is telling me that it doesn't matter what x is, x can be anything, no matter what x is, the y value is always going to be 7/2. Right there. So there's the value, 7/2. So it's a horizontal line. And the rise over the run, the change in y over the change in x, notice is going to be 0, because there's never any change in y at all. So the slope of a horizontal line is 0. Okay, so that's called a constant line sometimes, or a constant function. Okay, So there's a special case. Here's another special case. If you let b be equal to 0, then you could have 2x is equal to 7, and so x is equal to 7/2. What's that going to look like? Now we're saying we don't care what the y value is. No matter what the y value is, no matter what the y value is, the x value is always going to be 7/2. So there's the point 7/2, 0, and it just is a vertical line. Since the slope is the change in y over the change in x, and since the change in x for any 2 points along this line is always going to be 0, recall that we can't divide by 0, so this line would have no slope. Sometimes you might say it has infinite slope, but it's probably better just to say it has no slope at all, okay? So if you were to walk up that hill, you couldn't, right? It's just a wall. Very good, okay, let's try another one just for practice. I've got this one down. Let's say sketch the line. That goes through the point, passes through, should we say 2, 3? Let's say 2, -1. And slope of that was a negative, let's say slope of 3/4. Okay, so what's that going to look like? So first of all, it goes through the point 2, -1. So I go 2 in this direction and 1 in that direction. So I know it goes through that point. And now it has a slope of 3/4. Whoops, 2, -1. That's a -1 right there. Let's put that up just a little bit higher maybe. There we go. -1, -2, -3. Oh, there we go. So it has a slope of 3/4, which means what? This is the rise, this is the run. So if your run is 4 units, 1, 2, 3, 4, you go over 4 units, you're only going to go up 3 units. So 1, 2, 3, 4, so I'm right here, and I go up 3 units. So there's 1 unit up, there's 2 units up, there's 3 units up. So there's the point right there. Okay? So all I need is 2 points to determine a line. Is that a nice straight line? Its rise is 3, 1, 2, 3, and the run is 4, 1, 2, 3, 4. So there you go. Slope of 3/4. Okay, very good. By the way, 2 important things you should know about lines and slopes. One of them is very obvious, the other one not at all obvious. If you have 2 parallel lines, what's true about the slopes of those lines? Would you agree that the rise over the run of each of them would have to be the same? If they're parallel, they're both moving up or moving down at exactly the same rate. So the slopes are parallel lines. Slopes are equal. Okay? Perpendicular lines. What does it mean to be perpendicular? They make a right angle with each other. Those 2 lines are perpendicular. Let's choose a couple slopes here, lines here that are perpendicular. There's a couple lines. Let's call them L1 and L2. Okay, what do you notice about the slopes of these lines? It looks like one of them is positive and the other one is negative. That certainly is the case. Also notice that one of them, this one, the slope is pretty small, and this one, the value of the slope, the absolute value, the size of it is pretty big. See that? So not only is one positive, one negative, but the smaller the one is, the bigger the other one is. So perpendicular lines the slopes, if this has slope m1 and this has slope m2, then it's the case that m2 is It's the opposite, and it's also 1 over m1. So the bigger this is, the smaller this is. The bigger this is, the smaller this is. Okay, they're inversely related, and also by a negative 1. So in other words, another way of writing it is that m1 times m2 is equal to negative 1. So maybe this slope here is 1/3, and so this slope there would be negative 3. So negative 3 times 1/3 is negative 1. If you have two lines where this slope here is 2/3, then this slope here would have to be negative 3/2, because negative 3/2 times 2/3, you cancel and you get negative 1. Okay? There you go. Very good. Finally, just a couple applications of lines, especially with regard to the meaning of the slope. If you were out for a nice afternoon walk, maybe you're on a jog or something like that, and you kept track of the time, and you also kept track of your distance, and after maybe it was a long walk, and so here's your time, and here's your distance. We'll let distance be y. We'll let this be the t-axis. Instead of x, we'll let it be t for time. And say after 1 hour you had gone 3 miles, and after 2 hours you were just going at the constant rate, you had gone 6, and after 3 you'd gone 9, after 4 you'd gone 12. Well, what's that going to look like? 1, 2, 3, 4. I'm going to make this a different scale. I'm going to make this, let's see. Well, I tell you what. Let's make it the same, just to help you see what's going on. So 1, 2. Let's go a little bit farther than that. 1, 2, 3, 4, 5, 6, 9, 10, 11, 12. And here's 1, 2, 3, 4. So this is hours, and this is y miles. And so after 1 hour, you've gone 3 miles. After 2, you've gone 6. After 3, you've gone 9. After 4, you've gone 12. And so if I'd done it right, you just got yourself a nice straight line. And the slope of that line, take any 2 points on it, the change in y divided by the change in x, take any one you want here, take this one minus this. 9 minus 3 over 3 minus 1 is 6 over 2, which is 3. No matter which one you take there, this is always going to be 3, and the slope is the speed, miles per hour, right? That's miles per hour. So that's the idea. Let's just do one more, just to show you various things. What if you're measuring circles? You have a bunch of circles that you're measuring, and you're measuring their diameter is x, diameter in, say, inches, and here you've got y is the circumference in inches. Okay, so you've got a whole bunch of different circles here. In each one you measure that, and then you measure the distance around. And if you do that, you're going to get something like this again. Well, I guess it won't go negative, will it? And if you have 1 inch for the diameter, turns out the circumference will be roughly 3.14. If you go 2 inches for your diameter, the circumference will be around 6.28. And so the ratio of the change in y over the change in x is just going to be this slope right here, which is going to be 3.14, which is of course the value of pi. Okay? Let's try one more. I wanted one. You'll see why I want this last one. A friend of mine just emailed me this morning, asked me if I was interested in hiking to the base camp of Mount Everest with him. And apparently it's not too expensive and a lot of fun to get to the base camp, and then you just stay there. You can see the base camp of Mount Everest. And so let's say that this is your altitude here, and this is the atmospheric pressure here. And I'm actually not sure if this is a linear relationship or not, but I know it's a relationship which is negative. Okay, it's one that's negative, because as your altitude increases, your pressure is going to decrease. And by finding the slope along that, you're finding the rate at which the pressure is decreasing as you rise in altitude. So that's the idea. Okay, very good. So next time we're going to get into, just spend more time with lines. There's a lot to be said.